Okay, let's go over the exam. So, all right. Problem number one, you had a characteristic equation, s to the fourth plus s cubed plus 3s squared plus 2s plus 2. And the question was determine the number of roots in the right-hand half plane. So perfect to do Ruth Hurwitz. So here's our row S4, S3, S2, S1, S0, right? That's our first step to go ahead and start to build the row. Well, the Ruth Hurwitz table. We grab the coefficient from the highest order S term, then we skip. And then we skip again. So we have 1, 3, 2. Then we move down to the S3 row, and we see that 1 is at the S cubed, 2, and then there is no S to the -1 coefficient, right? So we just put that as a 0. So now we're going to go ahead and start building. And a lot of you folks forgot the -1 over the coefficient that's right there, right? So you put the determinant term, but you did not include the -1 divided by the term that's just above. So this is going to be the determinant, which means it's 1 times 2 minus 3 times 1, which gives you an answer of +1. Okay. All right. All right, moving on to the next one. So again, we use the first row, -1 over 1. And then our determinant now is always the first row, or first column, and then the column to the right of where we're evaluating. So that's 1 times 0 minus 2 times 1, which should give us 2. So now I've got to look a little bit, and I can see that I've got a 1 here, 2, and 2. So I know when I do the determinant of that, it's going to be equal to 0, right? But let's go ahead and do it. So I have -1 over 1 again. So I have 1 times 2 minus 1 times 2 equals 0. And a lot of you all, unfortunately, made this mistake. You immediately substituted E in here. What should you have done? You should have first checked the next coefficient, because if you have a row of zeros, you can't use the E term, right? You have to use the auxiliary equation. So I can't just substitute E. I have to go first and check. And we talked about in the study, the exam review before. We said it's a 3-step process. Do part 1, get a 0 in the first row, then check if the second element is a 0 as well. If it isn't, go back and substitute E. If it is a 0, then you're going to use the auxiliary equation. So let's check and see. -1 over 1. We have sorry, 1 times 0 minus 0 times 1. What do you know? We have a row of zeros. So I'm not substituting in E. I have to find my auxiliary equation. And I go to the S2 row to find my auxiliary equation, which is 1s squared plus 2, right? Now to get the coefficients for the S1 row, I have to take the derivative of that with respect to S. And some people have forgotten how to do derivatives. The derivative of S squared is 2s, right? Not 1s. So now I have the coefficient of 2 in there. Okay? Not E, but 2. So now I can go ahead in -1 over 2 times 1 times 0 minus 2 times 2 is equal to a +2. Sanity check your work. Remember, my last term should end up over there. I think if you did the E approach, I'm not sure, but I think if you did the E approach, you didn't end up with a K, that last term working out for you. So how many sign changes in the first column? Positive, 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 not positive or negative, right? It's 0, so not really a sign change. So positive. How many sign changes in the first row? 0, which means 0 right hand half plane poles. Questions on that? Make sense? Don't make sense? Any further discussion on this one? I'm not sure if people are mesmerized, or should we just keep going to number 2? Okay. Lucky number 2. So we had a block diagram. And we had a feed forward S times S plus P. And then we had unity feedback, and this was plus minus. And I said, if K is equal to 4, find the value of P so that the system has a overshoot of less than or equal to 5%. Right? That's the first part. And then the second part is the settling time is less than or equal to 4 seconds. So what we have to do is we're going to assume that this is a second order system. So we have to solve for our zeta term, right? Our percent overshoot equation, if you remember, is equal to 100 e to the minus pi zeta over the square root of 1 minus zeta squared. So I need to solve for zeta to figure out, what that value is. So the first thing you do is solve for zeta. And when you do that, I had zeta is going to be greater than or equal to 0.69. It can't be less than that, because less than that means it's less damping. So it has a potential to overshoot. So your zeta term is going to be greater than 0.69. My settling time, my equation for settling time is 4 over omega sub n, right? So it's possible to solve for omega sub n, but let's go ahead and see if we can get P, because we know what zeta needs to be greater than or equal to. Let's go ahead and see if we can solve for that. So the first thing I have to do is I have to do block diagram math to get a characteristic equation. And so this simple block diagram has G over 1 plus GH, which is equal to 4 over S squared plus PS, all over 1 plus 4 over S squared plus PS. We do common denominator and we invert and multiply, and we have S squared plus PS plus 4. Okay. All right. So this has the form, at least the characteristic equation has to have the form of that. So we know omega sub n squared is equal to 4, which means omega sub n is equal to 2. So 2 zeta omega sub n has to be equal to the coefficient P. So P is going to be equal to, P is going to be equal to 2 zeta omega sub n. When you plug that in, my value of P, 2.76. Now I'm going to check my results, because I should have a settling time less than 4 seconds, right? If it's less than 4 seconds, it's okay. If it's greater than 4 seconds, it's not. So when I plug in my value of zeta and omega sub n there, I get 2.9 seconds. All right, this is using zeta and omega sub n. If you wanted to use this equation over here, you could have also said zeta is equal to P divided by 2 omega sub n. So you could have just said that that's equal to 4 all over P over 2, and then you have 2 omega sub n's. You could have done it that way if you wanted to write it as an expression of P, but that was not necessary. And that was it. Solve for the value of P. Any questions on number 2? All right, number 3. So we have a characteristic equation, s to the 5th, plus 3s to the 4th, plus 2s squared, plus 7s plus k. And it said, find the value of k that results in a stable system. So what approach should I use to solve for that? You wouldn't do it? So you want a 0 on this problem? Yeah. You have a coefficient that vanishes. So if you saw that, you didn't have to do any work. If you wanted to do the work, certainly could have. S to the 5th, s to the 4th, s cubed, and I'll just start. I'll stop when we're running out of, we don't need to do more. 1, 2. Actually, no, not 1, 2. What's the value that should be there next? 0, right? Because this coefficient is between the 4 and the 2. So it's 1, 0, then 7, right? This is 3, then 2, and then k. So let's go ahead and build here. -1 over 3 times the determinant, which is 2 minus 0 times 3 is always going to be equal to -2/3, right? What value of k will make -2/3 positive number? I don't see any value of k that's going to make that a positive number. So you're done. You didn't have to go any further than this. Stop right here. Because I cannot adjust k to make that first coefficient in row S3 a positive number preventing a sign change. So that is a minus. I'm out of luck. I'm done. You are welcome to do more work, but what's the point, right? There's nothing you could have done to make that work. So 2 ways, either one was valid. Not a lot of work too, right? I mean, if you saw it, you could have made it a lot of work, but your results would have been, I don't have any work. This was probably the hardest part. If you did decide to do the Routh-Hurwitz, you got to make sure that you put that 0s cubed in line with the s4th and s squared term. Otherwise, if you did the Routh-Hurwitz tabulation, you wouldn't get good results. Okay? Questions on that? Anybody have any heartburn with this one? Was I being too sneaky? We did talk about this, right? I said, do the couple things first, right? Step 1, don't even bother if you have sign changes in your characteristic equation. You're done, right? Step 2, Any term coefficient vanishes, you're done as well. You know it's an unstable system. So, or you always have at least one pole in the right-hand half plane. So you had no calculations. If I asked you how many there were, then yes, you would have done the work, but that's not what the problem is. The problem says find the range of K that results in a stable system. And there is no range of K. Number 4. Nobody's complaining yet, so I don't know if that's a good thing or a bad thing. This is G4. Find the closed loop transfer function or the overall transfer function for this. So the first thing we're going to do is put this one in put that one in feedback. So we have a summer, and this becomes G over 1 plus GH. So that is, oh, I said G2, this should be G3, sorry. G1 over 1 plus G1, G3. And now I'm going to add that in because it's just in cascade. So that multiplies by G2. Now I have a feedback path. This is G4. And this is G3. Now I've got another feedback path. So G1, G2 over 1 plus G1, G3, all over 1 plus G1, G2 over 1 plus G1, G3 times G4 is the equivalent of that. So I've got to do common denominator. G1, G2 all over 1 plus G1, G3 plus G1, G2, G4, right? When I do common denominator and I invert multiply, and then I tack this one on in cascade. That's it. Do I have a G5? Oh, I called it G3. This should be G5. Sorry. That's G5, not G3. Did I write G3? Yeah, I wrote G3 here. So this is G5. So it's G1, G2, G5. Let me clean that up a bit. All over 1 plus G1, G3 plus G1, G2, G4. Oh, we'll take a look after so I can see.
Yeah.
Any questions on that? Number 4. All right, number 5, which may have been the second easiest problem on here. I said, given a transfer function, find zeta, omega sub n, and omega sub d. Well, this characteristic equation has to look like our second order approach. So omega n squared equals 4, which means omega n is equal to 2. Check. 2 zeta omega sub n has to equal 2. So zeta is equal to 2 over 2 times omega sub n, which is equal to 1/2. I said 1/2, then I wrote 1/5. And then omega sub d is equal to omega sub n times 1 minus zeta. Zeta squared, sorry. So that's equal to 2 times 1 minus 1/2 squared I think was the square root of 3, and you did it all out. Because if you move the 2 into here, right, that becomes 4 minus, well, I'll show you. Let's try it this way. So this is equal to, if I move this into the square root term, that becomes 4 minus one's just I can't talk about. That's 1/4. That's equal to 4 minus 1, which is equal to the square root of 3, if you want to do it perfect. And that's it for the tests. Questions on the test? Or comments? Fair, not fair? Too hard? Too easy? Thought it was right in the middle? Most people were done, I think. I don't think anybody stayed past. I think it was 4:30 was when the last person was done. So most people were done within 2 hours or so. So it didn't seem like time was a constraint. Any of the concepts or topics didn't make sense? Messed up 3? You didn't see the S cube term? Okay.
I mean, after I wrote down the answer to that question, I probably stared at that for 5 minutes. It was like, is that really what I'm doing?
Why?
It was.
Was it too easy?
It felt.
If you know the concepts, right? It is easy, isn't it? It's not meant to be mean, but it is. It's like, yeah, it doesn't meet the rules. We have 2 necessary but insufficient conditions. If those aren't met, then they are implying because they're necessary, then it's an unstable system. A lot of engineering sometimes is just that. It is that easy if you understand it. How about TV land? Any comments?
Thought it was fair.
Okay.
Yeah, I'm glad we didn't have to move pickoff points and summing junctions.
Yeah. That'd be for the final, right? No, and you know, the thing is too, is like hopefully everybody had a lot of time and were prepared, and because this test covered quite a long time of material. But yeah, I think it went pretty well for the most part. And the other thing too is like, did you even need to use your calculator on any of this? Did you need to use your calculator, or do you want to use? There's a difference.
Definitely needed it.
Which part? Number 5, we just did it with algebra, right?
Yeah, but I use the solve function rather than manipulating equations. So when I'm finding the value of zeta, then I'm using a solve function, and also to help me with the block diagrams and to invert and multiply, I use different variables, and I have my calculator actually help condense those equations. So
Okay.
quite a bit. Yeah.
Okay. I guess for me, the only problem I would have needed to use a calculator was this one, because to solve for zeta, you needed a natural log, and that would have been pretty tough. But if you're more comfortable with algebra, I guess maybe is a good way to say that, then you really don't need calculator for much of this, because this is the only problem I would have pulled it out. The first problem is just getting a bunch of integers, right? The second problem, yes, you needed your calculator. The third problem, you didn't have to do anything. The fourth problem was just a bunch of variables, and the fifth problem was, hopefully pretty straightforward. All right, any other questions? Should we start in a new material, or should we keep our approach of just doing the exam go over and letting you go for the day? What do you think?
I like that.
You like going over new material?
No, I like the other one.
Ah. Do we want to do a vote? Who says stay and start root locus? Raise your hand. Couple people. Who says call it a day? I only see one hand up for call it a day. Oh, that's two. So I'm the deciding vote, right? Because we only have 2-2. Oh. I guess it's 3-2. So, all right. Well, I guess I will let you out. So have a great day. And I'll see some of you in a little bit. If not, have a great weekend. We'll talk to you later. Take care, everyone.
Thanks, Paul.